So second question. So design a communication system. This is what we are using as a fundamental architecture for the common communication system using time division multiplexing. So basically it's a still multiplexer design. So we will added a demultiplexer here. So for the 8 channel transmitted signal has to, so this 8 channel transmitter and receiver, they have to share one communication channel or bus. So we have to have 8 to 1 multiplexer, and then on the receiver end, we have to have a 1 to 8 demultiplexer. So for this one, let's have a look at the solution. So this is the diagram of it. It's exactly like the slides we were saying. Okay, so time sharing, meaning we have the 3-bit clock divider. To later on, we will see how to build the counter as this clock divider. So it's the same as counter, 3-bit counter. So what's happening here is it takes this clock input and counts the number of the clock and then outputs the counter value 3-bit. So basically every time the clock tick, we have a triangle here. That means no bubble means the clock we're using is the rising edge of the clock. So every time the clock is on its rising edge, the output Q2, Q1, Q2, Q1, Q0 will add 1. So it will be like the pattern 0, 0, 0, 0, 0, 1, all the way up to 1, 1, 1, then back to 0, 0, 0, then just continuously counting that way, non-stop. So this one and this one are the same, So clock in, they have the same clock, means these two clock divider are synchronized. This is a synchronous signal. They are synchronized by this same clock signal. Okay, so having clarified this, let's see the output. So at a given time, these two, DEMUX and MUX, they will receive the same pattern of 3-bit input. Okay, so when it's 0, 0, 0, so for the first clock cycle, both of these two output 0, 0, 0 for 1 clock period. We can say that 1 clock period is, let's say 10 nanoseconds, or might be too short. It could be 10 nanoseconds if you are running a 100 megahertz clock, which is the clock you are having in the lab. Right now is with digital board you have. Next semester, it would be the microcontroller board. So both of these two boards that you're using has the 100 megahertz clock with it. So for 100 megahertz clock, every clock period is 10 nanoseconds. So it's every clock tick is 10 nanoseconds, and then the next clock. So when it's the first time the clock start running, both are 0, 0, 0. So for this multiplexer, 0, 0, 0 are connected to S2, S1, S0. So channel 1, channel 0 here will be selected and switched to the output. So channel 0 will be connected to the output, and then wire this channel to the DEMUX input, okay, for 10 nanoseconds, for 10 nanoseconds. Next clock, when there is a next clock, so the output of these two clock divider here will be 0, 0, 1. I haven't finished the last 0, 0, right? So 0, 0, 0 for for this DEMUX, it also will select the output channel 1 because the control is the same 0, 0, 0. So for next clock, when it's 0, 0, 1, so on the multiplex side, on the input side or the transmitter side, channel 1 will be switched to this transmission or communication channel output. And then this will be passed to the input of the demultiplexer. And on the demultiplexer side, the control signal is also 0, 0, 1. So it will send this signal from input D to Y1 to this channel 1 here. So these the two, the transmitter side and the receiver side, they are both 8 pairs of transmitter and receiver, but we can control which pair will be sharing the communication channel, communication line, right? So that's why we call this time sharing. So what is its name? In a time multiplexer? Time division multiplexing, so TDM. It's also, you can just remember it as a time sharing algorithm here. So basically every channel get to use this communication line for 1 clock cycle and then switch to the next channel until it's switched to the last channel, channel 7, then you will go back to channel 0. So it will repeat this way. So this is the design, the fundamental design of communication system, the transmitter side and receiver side, right? So